Hello. As promised, I'm going to do a video series to explain the derivation of the standard deviation formula. So this video series should cover how we start from intuitive understanding of standard deviation. We're going to start from a graph. We can actually see what standard deviation is and how it transforms into a formula that is not so intuitive and not so recognizable, the one in your textbooks and in your notes, right? But in order to explain that, there is a prerequisite concept that I must first explain, and that is summation. So summation is usually represented by this symbol you see on the screen. What is that? So that is just a Greek alphabet, kind of like your alpha, beta, gamma. Okay, but this one is called sigma. Sigma. So for those of you who are keen physics students, you might be thinking, hey, wait, I learned in school that sigma is this. And you're right. There are actually two sigmas. One is the capital sigma, one is the lowercase sigma. The one that we are going through today for summation is the capital sigma. So you can think of sigma as the letter S equivalent in our English alphabet. So where do we see the sigma sign and what does it look like in your textbooks or in formulas? Right, this is what you usually see, and I'm going to try to be a bit more layman. Yeah, you can see the summation sign in the middle, and then there's something on top of it, there's something at the bottom, there's something to the right of it. Okay, I'm going to explain to you what all these things around the summation sign means. So first of all, let's expand it out. Expanding out the summation sign, right? There's actually a lot of things going on over here. And it's all represented on the right hand side. It is very simply 1 plus 2 plus 3 plus all the way to n. And why is that so? So let's start from the bottom here. It says I equals to 1. This basically just tells us what number to start with. And if you look at the right hand side, our starting number is 1. It's not 0, it's not 2, it's not 10, it is 1 because we wanted it to start from 1. And you would have guessed it, the one on top tells you where to stop. So our last number to add over here is n. Okay, so far so good. Next, let's talk about this one. What is I? Right, so I is actually just a variable. It takes on many different values, right? So on the right hand side, I could say that we're actually adding up I n times. Yes, but this I changes value every single time. Now, the first I is going to be here, our instruction at the bottom of the summation sign, saying that, hey, we're going to start with I equals to 1. And the next one is going to increment by 1. It's going to be 2. The next I then will be 3, so on and so forth until we reach the last I, and that's n. So summation of I is very simply summing up all the different values of I, because I is a variable that changes. So very simply, it is just the sum of 1 to n in this example over here. Yeah, pretty cool, right? How we can shorten such a long expression on the right hand side into something so compact on the left hand side. But what has that got to do with statistics, and what has that got to do with us? Standard deviation, what we're learning. So suppose we have the height of 4 students, A, B, C, and D, and I want to represent that as a table over here of ungrouped data, right? Typically in your practice questions, you'll see that, hey, the variable we're going to use to represent the heights is x. X can take on many different values. It can be 100 centimeters, which will be the height of student A. If it was 130 centimeters, then it will be the height of student D. That's our variable x. And the first thing that we want to do is to sum up all the different values of x. That will give us 460 centimeters. So the thing that you notice is that, hey, wait, there's nothing at the bottom and the top of this summation sign. Why is that so? So in statistics, when we use a summation sign, it is implied that we are going to sum up all the pieces of data. Okay, so in this question, we have 4 students and there's 4 pieces of data. So when we use summation, we're going to add up all 4 pieces or all 4 heights. Okay, suppose the question was 6 students, then I will have to sum up all the heights of the 6 students. Okay, so once again, in statistics, it is implied. For summation, we're going to add up all the pieces of data. Okay, So after adding up all the heights, 460 centimeters, what's next? Why is this useful? Because we're going to divide by 4, the number of pieces of data, to get the mean. Yes? So that's helpful in that way. We sum up all the values, divide by the number of data. Right? That's the mean. Okay, but this thing can be quite troublesome to write. Summation x divided by n, summation x divided by n many times. Right? So we have a short form. Right? The short form is just simply x with a bar on top of it. Yeah? X with a bar on top of it. So the bar is kind of like when you average things out, everyone has the same height in the bar graph, right? The bar, a flat bar. Yeah? So no surprise, this short form is called x bar. X bar. Right? Pretty self-explanatory, if you ask me. So one more interesting thing that I need to tell you before we move on to the derivation of standard deviation formula, and that is an interesting thing about the summation operation. Okay, suppose our 4 students, right? They found some magic beans. You know, Jack and the Beanstalk, magic beans, right? And all of them ate the beans, and somehow their heights doubled overnight. Okay? So now I have to find the new mean, the new average of their heights. What do I need to do first? I first need to sum up their new heights. And that is actually summing up 2 times of their original height, summation of 2x. And if you expand it out on the right hand side, you get 2 times 100 plus 2 times 110, so on and so forth. Right. Looking at the right hand side, we can actually factor out 2 from all the terms. Factorizing 2, this gives us 2 times of 100 plus 110 plus 120 plus 130. Now, this looks familiar because this thing in the brackets is actually summation of x, right? So I can write this whole thing as 2 times the summation of x. And why is this interesting? That's because if you look at what we started here and what we ended up with over here, it seems as though that we can move the constant 2 out of the summation sign at the front. Yes? And this is really important, right? Moving constants out of the summation sign. We're going to use that in the derivation process. So please keep that in mind, and I'll see you in the next video.